Hi everyone, today we will be solving this problem 3 sum closest from the leetcode pattern website under the two pointer section. So a prerequisite for this question is the 3 sum problem. So make sure you watch that video first and then come to this. The link for the video will be given in the description itself, so you can check that out. Now let's start with this problem. So 3 sum closest, we are given an integer array called nums and length is n, and we have other variable called target, and we have to find three numbers whose sum is equal to is the closest to target. So in 3 sum problem we had to find where the sum was equal to 0 or some target. Here we have to find the closest one and we have to return the sum. So let's see an example. So for example, this one, we have this array, and here we can see that the sum -1, 2 and 1, these three elements sums to 2 and the target is 1. So that is the closest one. Other than that, we can see if we take this -4, 1 and 2, so that will be -1. So that is not the closest one. So we can check out all the triplets and see which one is the closest one. So here we have the array and the target is equal to 1, the same example. Let me index this. So now we can think of one solution that is a brute force solution, which will take order n cube time, since we can compute all the triplets and then compute the sum of them. So all triplets, that will take order n cube time. So that is the brute force solution. And now we can try to optimize the solution. So in order to optimize this solution, we are going to use something similar that we did in the 3 sum problem. So what we do is first we sort the array. So let's see how this array will look after a sort operation. Now we keep two of the pointers. This will be the left and this will be the right pointer. And we had another pointer which was called fixed pointer. So we need that as well here. So this will be our left and this will be our fixed pointer, right? And left pointer, right pointer. So now if we compute the sum, and so f pointer points to -4, then and plus -1 and then plus 2, right? So this will be equal to 3, -3. And currently, let's say we have a variable called result, which is storing the sum. So we can keep it initially to 0 and we can keep a minimum difference. So minimum difference MD, that I'll keep to maximum. So int max. So these are the two variables that we need. So right now we see that sum is -3. So now we can calculate a current difference. We can directly, if we directly do something like sum minus target or target minus sum, we can have both of these values, right? But we need only one difference. So in order to have just one difference, we can put the absolute function, and then we can do the current sum, which is sum and minus the target. So doing this, we will know how close our sum is to the target, right? So this is the current difference. Now we can check if the current difference is less than the minimum difference. So initially minimum difference was like infinity. So current difference will be, of course, less than that. So current difference is absolute of the sum, which is -3, and minus the target, which is 1. So this will come out to be 4. So initially we will set the current difference, the minimum difference, sorry, to 4. And the result will be equal to the sum, that was -3. Because in the end we have to return this result. That's why we are storing this extra variable, right? And now on the other iteration, let me draw the array again. So we had the fixed pointer here and left pointer here and the right pointer here. So now we can see that the current difference, if we see here, was equal to 4 and the current sum was equal to -3. So -3 we have here. Let me draw like a line. So let's say we have -3 here and the target is here. So this is the target. So we want to move closer to it. That means we want to increase this sum value, right? This sum value should go up. So in order to increase, we know that we move the left pointer, since that is pointing to the lesser value. So now we do the same thing. We move the left pointer here and then again we compute the sum, do that entire same thing. Then we again move some other pointer. So then we will move the FP ahead. Then same process we will repeat. So at last we will get a result which will be equal to 2 and we will get a minimum difference. So minimum difference is not needed. to return, we have to return this. So this will be our answer. So that is how we will be arriving at the solution. And the time complexity for this will be order n square, since we are moving one of the pointer, which is fp, and for every time we move fp, we are also moving the lp and rp, right? So that will be inside the loop, so we will have two loop inside, so that is order n square time, right? So let's start with the code of this question. So first I'll do a boundary check. Let's say that the size of nums is greater than equal to 3, since we need at least 3 elements. Then we can keep a variable called res, which will point to 0, and a minimum difference, which will be int max. And now we need a fixed pointer, which will move through the entire array, and we need to move it till the nums dot size -2, since we need like 2 elements at the end, and fixed pointer plus plus. So that will be it. Now we keep a left pointer, which will be equal to fp plus 1. We keep a right pointer, which will be the last element 1. And one step I forgot was to sort this. So let's sort the array, nums dot begin and nums dot end. Now after that, what we will do is we will compute the we will run the two pointer. So that will be while left pointer is less than right pointer, we will compute the current sum. So current sum will be equal to nums of the fixed pointer, nums of the left pointer, and nums of the right pointer, right? And then we will compute the current difference, which will be absolute of current sum minus the target value. Now we will compare that if the current difference is less than the minimum difference. So in that case, we have to update the minimum difference. So minimum difference will become the current difference, and the result will be current sum. Now we have to move both of the pointers. So if the minimum difference was equal to 0, that means we have found the closest and we can return the result. Otherwise, what we will do is we will see if the current sum is greater than the target. That means we want to reduce the current sum. So in order to reduce, we move the right pointer. Otherwise, we just move the left pointer ahead. And at last, what we will do is we will return the result. So I think this looks fine. Let me try it. Let's run the code on the example cases. So the output is fine, that is true. Let's submit the code. So we can see this is accepted. So this was it for the video. Thanks for watching.